Now we will be seeing the actual experiment itself. We have a helium neon laser. You can substitute it for any other laser also. And we have a lab jack on which this laser is put. And this lab jack is used to adjust the height such that this lab jack, this optical chopper, and the detector are in line in two axes. They have to be in line in this axis as well as in the height. So this is the laser. And then we have got the optical chopper and its controller. This controller can be used to adjust the speed of the chopper such that we can get any number of pulses per second, so that the experiment can be repeated a number of times by adjusting the speed of the chopper and getting different pulses. And we have the detector here. This is the same detector we used before, and this is connected to the oscilloscope. And this oscilloscope records the voltage of the output of this one. And then we have the optical detector. This is the detector head. And once we finished with the measuring of the pulse parameters, we can measure the pulse average. As you can easily see, there are 3 pulses shown here. So if we measure from the beginning of this pulse to the beginning of the next pulse, that will give us the PRT. And we can adjust the height of this pulse also and measure the width in times in here, which is our theta delta T half, which is the full width at half maximum. So with these two and the P average, we can calculate all the parameters. As we have seen, that once you multiply delta T half with the P average, that gives us the energy. And then once you know the PRT, the reciprocal of PRT is PRR. So once you know the P average as well as P maximum, you divide one by the other, it can give you the duty cycle also. The great advantage of this experiment is that you can do this experiment with a very simple setup with an ordinary Heine laser and reproduce the idea of how a pulse looks like and how the pulse parameters can be changed and the pulses can be measured. As already mentioned before, the pulse lasers are much more efficient and much more useful than CW lasers for a simple reason that in the case of the pulse laser, all the pulse parameters can be adjusted. You can adjust the pulse width, you can adjust the pulse height, you can adjust the PRT, therefore PRR, you can adjust the duty cycle also. So which means that for a specific purpose, you can make the pulse suitable. Later on, when you actually deal with the YAG lasers, where they are both pulse lasers, and you have got the Q switching, mode locking, everything will be there. These things will you will read in the higher level of laser technology. These two experiments, this experiment and the longitudinal modes will give you a very good idea of what a laser is and how it is different from an ordinary light.